Okay, so we're going to look at energy levels, sublevels, and orbitals. All right, so we represent each of these things using quantum numbers, and you'll run into these more as you get into more advanced chemistry. So if you're planning on continuing on and learning more chemistry, you'll need to know these. Your principal quantum number, which is represented with a lowercase n, is your main energy level. This equals the distance from the nucleus. So like if you have principal energy or principal quantum number of 1, you're the smallest, lowest energy state. It's closest to the nucleus. If it's a 2, it's farther out. 3 is farther out even than that. 4, 5, and so on. And it just keeps getting bigger and bigger and bigger and farther out, which is why atoms that have a lot of electrons are a lot bigger than atoms that don't have hardly any. Like hydrogen's the smallest atom, and it only has 1 proton, 1 neutron, 1 electron. Whereas something like carbon is much larger because it has 6 protons, 6 neutrons, 6 electrons. And so their shells are much different sizes, and they're on different energy levels even. Okay. So each of these numbers drill deeper towards a specific electron. So think of this as like the electron's address. So different types of notation use some or all of these numbers to describe the electron configuration of a specific atom. So everything will always have the principal quantum number, that's the shell. Every kind of notation uses that because it's really important. Then your angular momentum quantum number is represented by L, and this is the shape of the orbital. Your angular momentum quantum number will be equal to your principal quantum number minus 1. And that tells you what kind of shell or subshell you have. 0 gives you s orbitals, 1 is p orbitals, 2 are d orbitals, 3 is f orbitals. We call these subshells. Magnetic quantum number tells you your orientation of the orbitals within the subshell on the XYZ axes. So we're going to see a picture of these in just a second, and they can be around the x-axis, the y-axis, the z-axis, and in the case of the shells that have lots of different orbitals, it can actually be between them. Okay, so like on diagonals. And so this is represented by m sub l, and it's all integers from negative L to positive L. So if L is 1, it would be negative 1, 0, positive 1. And so because L is 1, that's your p orbital, p subshell orbitals, you can see that there's 3 there. Okay, and that's true. P has 3 p orbitals in the subshell. And then the spin quantum number just represents your electron spin, whether it's up or down. Each orbital can have 2 electrons in it, 1 up, 1 down. And so these are your orbital shapes. Remember we said if it's a 0, it's an s orbital. That's the sphere. Okay. If it's a 1, it's a p. That's this dumbbell. Okay. And p can be oriented around 3 different axes. So this one's on the z. You can have one on the x. You can have one on the y. Okay. The d orbitals have 2 different shapes. If it's on the z-axis, it looks like this funny dumbbell with a ring around it. And then all other axes look like this clover shape. F orbital is like when you stack 2 Ds on top of each other. So it's an 8-leafed clover, basically. When it's on any axis other than the Z, when it's on the Z, it has a double set of rings. Okay. Now, the principal energy number tells you how big the orbital is in relation to the nucleus. So, for example, n equals 1 is a very small orbital. N equals 2 did not go where it was supposed to go. Is a much larger orbital. Give me just a second. Something is not where it's supposed to be. It didn't do what it was supposed to do. Hang on. There was an issue. I'm going to open this in PowerPoint and share that real quick because I really want you guys to see this, and it just did not work. So let's pop this open. All right, so technical difficulties aside, I'm going to just share my screen. Okay, for just a second. So this is what it was supposed to do. N equals 1. And then n equals 2 is bigger. Okay, and so you can see, right, if I click on that, you can see for just a second, you can see the smaller n equals 1 inside. And that's how it actually is in the atom. You'll have your n equals 1 s orbital, your n2, and then these p orbitals will stack on top of that, and they'll crisscross a little bit, which is why here in the center you don't find those p electrons as much. That's why that's smaller, it's dumbbell shaped. And so they keep stacking as you add more energy levels, and it just builds out and out and out and out and out. So that's all I really wanted to show you guys. Let's come back here. Okay. All right, so I will see you guys in the next lesson. Sorry for the technical issues.